morning, everybody. This is Tim, and I have a few of my colleagues here today and a little bit of housekeeping before we start. You should have a GoToWebinar panel, and on that panel, you'll find a questions area that you can enter questions in. My colleagues will be answering those questions if you put them in. We like questions. And if there's any leftover or things that are very, very much germane to compare and merge today, maybe at the end have time to dig into those. And with that, I think we'll get started. Today's lab is all about probably the most robust feature and most important, one of the most important features within Data Architect. And it might be one of the least understood because it is one of those things that is really kind of unique to Data Architect, at least how it thinks about understanding differences between objects and models and physical data sources, and how it actually works and organizes that. So let's jump into that. First thing we're going to do is talk about our agenda today. Just a quick refresher on what ER Studio is and what are its component pieces. We're going to talk about developing this data structure knowledge, that important, all important creating knowledge path that's going to be really key to what we talk about today with compare and merge. Again, Data Architect's most powerful feature, I think it is. Others may disagree, but it is definitely a feature that if you're going to use Data Architect and ER Studio to its fullest, you're going to have to understand compare and merge and its importance in the overall workflow of maintaining and designing your enterprise data program. We're going to look at some real world use cases, and then we're going to get to the fun stuff. I'm going to jump into the product and show you this. There's a lot of kind of bits and bobs, if you will, in compare and merge that people may overlook. I may turn on some light bulbs and say, "Oh God, I was really looking for how it did that, or I wanted to do that and didn't know it could." So there are some things like that in compare and merge. And then we'll do our conclusion and takeaways and get into questions and answers. All right, so let's jump into it. First, what is ER Studio? ER Studio really is a product grouping. It's a ER Studio Enterprise is an entire data modeling and data architecture solution. It really provides the basis or foundation for an enterprise data program. And it has all the standard features you might expect, like conceptual, logical, and physical data modeling. But you also, don't overlook the ER Studio web portal, which we call Team Server Core, that gives that team collaboration, all based upon a repository. We have ties to data governance, and you can do data lineage, and we have many, many different platforms that are supported that can be a part of your data program. So ER Studio Enterprise really has three pieces to it. It has Data Architect, where data modelers and data architects are going to spend their time doing those things associated with data modeling, canonical data modeling, hierarchical data modeling, conceptual, logical, physical, that all important reverse engineering path that we'll investigate and use today to really help discover and create knowledge about existing data sources and keeping that alignment. The compare and merge, that's what we're really deep diving in today's lab, and the other features there. And of course, Data Architect is just one part of the ER Studio Enterprise offering. It really revolves around this idea of the team server repository. That's your central source of truth for metadata objects. The repository acts as a gatekeeper vis-a-vis a check-in, check-out process. It provides model sharing and model versioning, where you can have many, many different modelers and architects working with the models either simultaneously or concurrently from the repository, really to support that really enterprise level view of a data management program. And of course, since that repository is your live single source of truth of those metadata objects, we have Team Server Core. You can think of this as your ER Studio web portal. And it allows really any other role within your organization to come in via standard web browser and see the great work that those modelers and architects have been working with defining, documenting, and describing. And the other thing that ER Studio Enterprise supports is through purpose-built integrations, integrations to leading data catalog, data governance applications such as Purview and Calibra. So this is kind of getting to what I wanted to talk about today now, and getting peeling back that onion, getting a little deeper. This idea of creating source or understanding data sources and creating knowledge about them. Of course, support many different data platforms, DBMSs, JSON, all sorts of data sources that you may have and that do exist across your entire data environment. And you point data architect at it, you get back a physical model and a logical model. And with ER Studio, it's really that logical model where a modeler or architect would take that iterative process of fleshing out, of really adding that really important and supplemental information using naming standards, templates, and attachments and data security properties. Is it PII? Is it GDPR or HIPAA? All that knowledge that doesn't really exist when you're looking at that physical structure on a data source. It's really that idea of creating that knowledge. And of course, once you have that knowledge, you can tie that in to your data governance, as you're seeing terms in a taxonomy here within a glossary. And I'm sure a lot of we have great visualizations in Team Server Core to let you know, hey, where has that client term been related? Where has customer been mapped to, both at physical and up into our enterprise logical data model. And that's really going to be the crux of what we talk about today once we get into the product. So the enterprise model, right? Talk about this a lot. This ELDM, this enterprise logical data model. You can have this, and you can break this up any way you want. A lot of folks have domain level models. That's fine, but the concept here is to have that consistency, that master template of what in this case is a company, is a vendor, is a client, is an order. And then as you flesh that out, is it PII? What is the security and access policies? And you start adding projects, maybe you reverse engineer a relational database, or maybe you create it from scratch and forward engineer it into a platform. The idea is, if you have a company here in this project, let's use that master template for company from our ELDM to ensure identifying characteristics such as PII or critical sensitivity also are ascribed to it as well, right? The idea of that master template. The way the environment or way the ER Studio handles these are things called universal mappings, and that's these blue lines you'll see in these diagrams here. And these mappings are really part of what compare and merge can do for you, and I'll show you how that works here in a bit. And as you add more and more projects tying into data governance, sure, but really what I wanted to talk about and kind of dwell on as far as slides go today is this picture here, this idea where you're having that interconnectedness, that linkage up into a master template model, your ELDM, and helping using it to help ensure that consistency across your entire ER Studio data dictionary or a collection of projects, such that you might have subtypes or different types where client and customer are really the same thing, but you want to make sure you have that consistency of definition of what a customer or a client is, what a rating score is, what its dimensions are and defaults and reference values and those kinds of things, all to maintain consistency. And compare and merge can help with that. All right. So let's digging into compare and merge. Sure, if you go to our website and you look up compare and merge, you'll find these highlights. You know, and you can read about this. You know, side by side comparison, the intuitive interface, bidirectional merge, and all this stuff is absolutely true. But you're probably scratching your head and say, well, that's great. You know, I got documentation here, but how does this affect me in the real world for the jobs I got to do? So what we're going to do is dig into some real world use cases, cases I've used in my own professional life. And really, we have a top 3 or 4 of them that are really centered around what compare and merge does for you or can do for you. The idea of merging logical changes to a physical model, that's something that's unique in ER Studio. We have something called a logical model platform agnosticity. And what that really means is our logical models are not physically tied to any physical model that you might have in that same project. And that means you have the ability to create different physical models for the same logical model for different implementations, or have different physical models for different expressions of that metadata. Say you have an enterprise data warehouse based upon, you know, a data vault or Kimball design, but you have a data product that may be a JSON file or schema. All that can be designed in the same project and have different physical models with different physical capabilities. And that's something that's only available in ER Studio. Using the ELDM as the Enterprise Logical Data Model, I should say, in case you're not used to that acronym, as a master template. That's really the idea of that ELDM, that Enterprise Logical Data Model, becoming that hub, as I showed you on that previous slide, and maintaining those important mappings. And I'll show you how to do that with, it's often overlooked in compare and merge. Comparing a physical model to its data source, another great use of compare and merge, where you're really comparing. You may not merge so much here, but say you're in a situation, you're part of an architecture team, you're trying to get some rigor and some discipline around maintaining and the alignment between your data sources and your data program. Hey, compare and merge in that report feature, and I'll show you how to get to it. Is something great to use to, hey, have it look at a data source, have it look at your physical model and see if there's any differences, and if there are, what are those? Have the devs or the DBAs been sneaking in columns or other objects without the architecture team being involved? It's a great report to help drive you know, meetings and discussions about that type of you know, keeping that type of alignment. And then the last one I think we'll cover here today is the actual generation of the DDL, and by the way, JSON, which is a full-fledged platform for us. Both the initial create DDL or JSON schema, or with the with the, you know, relational data sources, or I should say DBMSs, create using compare and merge to create that alter SQL as well. So now we get into the fun part. So let's jump into my VM, and here what I'm going to do is the very first use case I wanted to talk about, just to refresh our memories. I probably should have, if I could figure out how to do it and be a little more snazzy, I'd have that in a little pop-up window we could refer to. But the very first one I wanted to cover here was merging logical changes to a physical model, right? So we have a model up. Those of you that have seen our demos, we use this HR database model quite a lot. It's fleshed out with all the a lot of the different facets and dimensions and ancillary supplemental information that you can add to a model, and it provides a great demonstration platform. And in this case, you could see we are a repository-based model. You see the green open padlocks. I've already checked it out for us today. You can see that this HR database model has been ported into many different platforms, and maybe it originally came in from SQL Server in this physical model. And what we're going to do in this first step is work from our main model here, or I could work from the training submodel that happens to include everything. Remember, submodels are windows into the main model at that level. The logical model and all physical models have the main model, so you can work in a submodel, and those changes would automatically be reflected into the main model at that level. So let's work in our training submodel here, and for fun today, say we had a request come in that said on our employee entity, we want to add I got a new attribute there. Let's add another one. Let's call it favorite color. Actually, this is logical level, so we'll write it out. Favorite color. And on the column, we can call that fav color. How's that? Chart 10. Sure, what you guys get it. We could set that up to anything we want. Say okay here. There it is. Say okay, and now it exists. If I zoom in here a little bit better for y'all to see, But by the way, a neat feature here, and everybody doesn't know about this one. I mean, check out this navigate relationships, especially if you're working with big models. Click on it, click on the relationship, and it'll scroll around for you. Pretty cool stuff. I always like to show that feature. I just think it's very, very neat. And there it is. Our employee entity at the logical level has favorite color. If I go to the main model on employee, there's favorite color there as well. But hey, look at our SQL Server physical model. Like the other physical models on the emp table, there's no fav color there. So how do you get that change from your logical layer into one of your physical layers? Well, anytime you need to know the difference between some object A and some object B, or merge changes from that object A to B or B to A, right into your brain housing group should jump the idea compare and merge. Just that quickly. It's what it's there for. So we're going to go at the logical level here. We're going to right click, hit compare and merge, run compare and merge utility, and see it brings up one of our magic wizards here. We use wizards extensively through the tool to make it easy to use. And in this wizard, it is very, very key to a lot of just those fundamental use cases. So let's take a look at what it's displaying for us here. So now we're on a logical model here. So you see we have different options we can choose. Notice some are grayed out and not available to be chosen. Those will be lit up for you if you start from a physical model, right? You can't compare a logical model to a physical, data source or physical data asset. You can only compare it to a physical model from the logical level. And that being said, I could compare our HR database logical model to another model in this file. That's the one we're going to choose. But notice here for our some of our use cases later, we're going to maybe choose these other ones. So in this case, and again, merging logical changes to a physical model, we're going to choose that and hit next. And our next here, what are we comparing our logical model to? Is the training DB SQL Server, and we're going to hit next there. And we're going to take all our standard options here, but there are quite a lot of options. These are all what you're comparing A and B. The different facets, the different things you can find differences. The different things you can find differences on. That's a great way to say that. The different items that can be compared on. How's that? Let's say it a little bit more clearly there. I'm going to hit next here, and we can compare all our logical entities here, or views, users, roles, shapes, all that stuff to our physical. But in this case, since we happen to know, we put it on employee to make this very clean so I can illustrate what it does for you. I'll just choose employee and emp. And here on the last page of compare and merge is your magic page, right? It's where you finally put it all together And this is where your final result can be expressed here. So again, pay attention. Your A, your what you're comparing is your HR database SQL Server to your target model SQL Server physical model. And on my employee, it's saying, yeah, we got different owners and that kind of stuff. But on the attributes here, in our logic, our logical model, we have there's that EPNUM, by the way. We'll get into that. But there's favorite color, and favorite color does not exist on our physical model for SQL Server. So we could ignore the rest and actually say we want to move favorite color into our SQL Server. So we're going to choose that resolution, merge into target. There are other options down here. We're going to get into these options on our next use cases. All right. So for here, we're just going to merge this into target, and we're going to hit finish. And now if we do that, we look on SQL Server, and we actually expand this out a little bit. Oop, let me grab that control. You can see that fav color. If I zoom in, maybe be able to see that. There's our fav color at column now on our EMP table, right? So that is the merging of logical changes to our physical model. So let's jump to one of our last use cases, since we happen to be here, and it fits in good here. Now that we have that change in our SQL Server physical model, we've added fav color. Maybe we could apply a naming standards template to it now and get this into the right physical level naming standards for this SQL Server implementation. My colleague John, who's with us today, did a great lab or webinar just a month ago that's available on our website using the data dictionary options and naming standards templates. So that's available for you there. The idea here is we'll just keep it at fav color now, because what I want to show you now is the next step in this kind of logical progression is from our physical model, right click and generate database. And actually, you know what we could do here? Let's do it this way. Let's do it this way. I want to go ahead and compare and merge this physical model against the physical asset, since we're really talking about compare and merge today. I was going to slice that a little bit differently for us today, but I think this will work too to get the point across for compare and merge. So we're on our physical model. We've added fav color as a column. So now what do we want to compare this physical model to? Notice that we have these new radio buttons available for us, and we are going to compare. We could compare this against a SQL file we have out on disk somewhere. Notice that we've added in an earlier edition, version, I should say, the ability to work with GitHub, GitLab, and we can compare this against the create file that you put in your CI/CD or DevOps. We could connect to that here, or we could compare against a live database. I'm going to actually choose that and hit next. And okay, we'll go ahead and get the repository option done. And since we're comparing against a live database here, I got the connection criteria. Just like if I'm doing a reverse engineer, I'm going to go ahead and put that connection criteria in, and I've chosen wisely. So now I can choose the database that I'm comparing against and say okay. Hit next here, and I just take all the same options and stuff. I usually don't do relationship names if I haven't worked with my naming standards templates here. And we know that the change is on the EMP table. Again, I showed you this, and hit next. And on our final screen here, we have the fact that fav color is in our physical model but does not exist on our database. What do we want to do? Well, there's a couple of use cases here. Now, we could have done the opposite. We could have found something that exists on the database that doesn't exist in our model. In this case, we have something in our model that doesn't exist in the database. So that's because we're rolling a change forward. But what if you had run compare and merge like I just did and found you know, a column or a table or any other object that you found as a difference? Well, you have this report button, right? So this report button is going to allow you to create either a Word RTF report or an HTML report of those differences. And that's when I was talking earlier, using that report to drive those meetings, to drive those conversations. Why is there differences between my physical assets and my physical models? If your physical layer is changing without the architecture team's knowledge. So that's that feature there. In this case, we did make a change to our physical model. We rolled it from our logical to our physical model. Now we're comparing the physical model against the live database. And what do we want to do with favorite color? Let's say we want to actually have favorite color in the schema for that SQL Server database. We're going to say merge into target here. I'll go ahead and say next. It's going to actually generate that DDL alter SQL file to this Windows folder. That's been the way to do that for any number of years. But notice we've also added the feature now. I can put that alter SQL DDL straight out into get and connect here. Get and connect, get it. I love it. I can connect to get right here. I can go ahead and choose that, put it in a branch and give it a commit message. But for us today here, I'm going to go ahead and create a DDL file for us. And if I hit finish, it's going to open up another little applet that's in Data Architect right out of the box, this universal ISQL, and there's our alter statement. So what have we seen already? We've seen a couple of our use cases, right? We've seen merging logical changes to a physical model and merging those physical changes to your live source through compare and merge and creating alter DDL, right? And we'll go ahead and click out of that. Now I want to show you, hopefully you've got that. I want to show you another very important use case. That's going to be using your ELDM, your Enterprise Logical Data Model, as a master template. All right. So we got the order, and I got a model here, order sales lab, right? So say this is a model that you either had or you've just created. We got an ordered entity here, just one entity. I've added a couple of attributes to it, O date and sales rep. And so say I wanted to use, instead of doing things from scratch like this, maybe what I want to do is create a model using my ELDM. So let's do a file new here instead. New relational. And now I have model 18 out here, brand new empty model. And I'm going to take this empty model and I'm going to do a right click and run compare and merge from this empty model. And the idea here, again, our use case is I want to use our ELDM as a template. So from our empty model here, you could do this from any model, by the way. I'm just using an empty to kind of illustrate the point. Got the same options. I'm going to compare this against a repository-based model file. Hit the folder, and that's going to open up our project hierarchy from our repository, and I'm gonna compare it against our corporate logical, our ELDM. Hit the checkout immediately because it wants to check out when it does this operation. I'm gonna hit next. Yep, that's fine. And I'll compare against. We can compare against one of the sub models. We'll go against the main model here, and we'll compare. Hit next. Now we're comparing. This is an odd looking screen, but remember our use case, right? We're comparing an empty model against our ELDM with the use case of, hey, let's bring objects in as templates. right, from our ELDM. And so let's say, remember our use case for here was, hey, we wanted order, maybe we'll take order and order line in. We'll hit next. And now on this page, this is that meat and potatoes page I want to talk about here. There's a couple of things here that are very, very important. One is the same thing. We're comparing our empty model against the LDM. What's our resolution do we want to do? Let's go ahead and let's go ahead and set all those resolutions to merge into current. Little arrow pointed this way. But we want for the future, we want this model to know, and when we put it in our enterprise data program, we want the repository, we want our environment to know that we've based these objects, brought them in from the ELDM. So there's a little button right here. Everybody misses it. It's called Save Matches. So if we click that, we get a little dialogue here. Typically saving all matches is there, but there is a lot of functionality here that you can dive into. Typically taking the standard options is the way to go there. And I'm going to say, okay, it's going to save those matches. And now if I hit finish, and let's go to my diagram, let's go to layout, hierarchical. And now in our what was empty model, we have both order and order line. That's what I've chosen, right? We've brought those in. And look, if I drill into that order entity, I get all the information, all the data types, everything's come in from that ELDM. And it knows, if you go to where used, it knows that this order entity came in from our enterprise logical data model, from the logical entity order. And those of you that use Team Server, I could jump into that very quickly. This is that same view Team Server. Let's say, hey, we're going to the employee, the related objects to employee. So here it is, the employee entity from, we used order, but you get the idea here. That employee was brought in from the ELDM. These are these universal mappings, linkage. So we're consistent across our portal, across the data, the actual data model itself, and it really all kind of gets its genesis, if you will, from the data model here and that connection. Here's another use. Here's another use of compare and merge that is very, very, people don't know about this one so much. Let's go back to this order sales where I created that entity and just threw in a couple of attributes. Let's go ahead and compare this. Do the same compare and merge operation. I'll do it quickly this time. Same thing. I'm comparing against my ELDM, and I'm going to compare this one just order against order, right? So I created this order by hand in this model. I'm going to compare it against our ELDM order. And look what I get when I get here. This is interesting. On our order entity, on our attributes, we have O date that I put in, sales rep, and on the ELDM, you have, obviously O date and sales rep doesn't exist, but we have these other attributes on our ELDM: order number, order date, customer purchase order, salesperson, customer reference number. Now, as a modeler and architect, I know what I meant. O date here, that's order date. So how do I make ER Studio understand that connection, right, between O date and order date? Here's the trick. It's in our docs, but it's buried. Nobody ever gets this until you've used the product. Select O date, right-click order date, match those objects. Look at that. Now it knows it's matched. Sales rep, right-click salesperson, match those objects, right? And now maybe I want to keep this entity, order date and sales rep, Do I want to bring an order number? I can go ahead and merge that into my current. Do I want to bring the customer purchase order number in? Maybe I do. You know, it's all up to, you know, your design work you do as a modeler and architect. Don't forget to save the matches. So I'm going to save the match from O date to order date, sales rep, this, and for the attributes I'm bringing in, hit save matches again, say okay. I take the standard. I could only save the forced ones, the ones I forced where the right click matches. I could just do that, but I want to save them all here and say okay here. And with any luck, if I hit finish here, go ahead and save that. Look what it's done now to our model. We've added in customer purchase order. We got a key for order number. It's actually figured all that out based upon compare and merge. And here it knows on that order entity that we've got that map to order. And yes, you're probably asking, well, that's at the entity level. Great. Do the attributes know that? Absolutely. If you go into an attribute, go to say O date in this case, go to where used here, you can see it knows it's on order all the way to order date on the ELDM. I'll bet some of you in the audience today didn't know about this feature and are going, wow. At least I hope you're going, wow. I go wow every time I use it. So that's really, let's take a look at what we wanted to talk about with our real world use cases here. So if I go back to where we once belonged, merging logical changes to a physical model. Remember our logical model platform agnosticity in ER Studio, a very important journey, and the ability for ER Studio to have that platform or logical platform agnosticity is just so valuable in the data product creation story and anything supporting your enterprise data warehouse. Using the ELDM as a master template, just went all through that and maintaining those mappings with that little checkbox I showed you that everybody overlooks. That makes those linkages. You can always, by the way, I should bring this up. You know, kind of a what if. Let's go back to data architect. If I'm on a model, let's see if I can do this. Probably need to be in a repository-based model. So let's go to a repository-based model, our HR database model. If I want to go ahead, we'll go back to our logical model here, and maybe, sorry, jumping around a little bit here because I thought of something else I wanted to talk to you guys about. So we're on our employee entity. Since this is a repository-based model, you see the padlocks. The repository knows about this and then can create those linkages, right? If you end up not wanting or haven't used compare and merge and you want to create those universal mappings, a little bit beyond what we're talking about today with compare and merge, but don't forget you can go to the repository and you can go to universal mappings here and you can set up those mappings yourself right through universal the universal mappings feature. Point I'm making here is if you do it and think to do it when you use compare and merge, it's a big time saver for you without having to go through and say, oh yeah, now I want to map employee. And there's also the extra added benefit of actually bringing in those items from your ELDM as a template. The other thing I wanted to show you too here while we're here is we do work with JSON. So here's a model based upon a library, you know, books with sections and chapters are in books and publishers, and books can be checked out by patrons, and patrons have an address, libraries have an address, and a checkout, all of that. So the idea here is you can actually do the create, you know, you can create the physical model, and here we've created it in JSON, and you have this this JSON physical model. Don't forget on these, you can go to your diagram object display properties on the object and show it rolled up if you like the JSON format, and there's your JSON file. What I wanted to show you here is is that you can do compares against using JSON as well, and compare that against another file, or bring it in from your another DM1 file, so you can compare JSON physical models as well. Okay, so let's go back to our PowerPoint. Those are our real world use cases, and what I wanted to show today. I think that brings us to questions. Let me take a look at those, and it looks like all of them have been answered. And so like to thank you for joining us here today. If you need more information or would like to hear about more about Compare and Merge or any other feature within Data Architect or ER Studio, scan the QR code or talk to your sales rep, sales@idera.com, sales@idera.com. On behalf of me and my solutions architecture colleagues, I'd like to thank you for joining today, and I hope you have a very good afternoon.